the last part of problem 1, last series that we need to find the convergence or divergence of. Again, we have an alternating series. This one's a little bit more complex than the last one though. So we have 2 to the n factorial divided by, so we have this product, or repeated product, of 3n plus 2 terms. Okay, so using the alternating series test here would actually be kind of difficult just because it's not very obvious what's going on with this limit. It might be a little easier to show decreasing, but in any case, let's just look at the series without the alternating, and we can use ratio test on that, and then we'll be able to see what's going on. So we're just going to focus on the non-alternating part, and we're going to use ratio test to see if that converges, because if this converges, even if we disregarded the alternating part, then it's absolutely convergent, and it converges anyway. So by the ratio test, we're going to take our n plus 1th term. So when you have a repeated product like this, your n plus 1th term is going to go here, and it's always going to add the coefficient in front of the n. So 3n plus 2, the next term would be 3n plus 5, because they're all 3 apart. So we multiply that by the reciprocal of our original. We have our original repeated product to the n factorial. Absolute value, but again, all these are positive because our n's are all positive. So let's see what can cancel out. So first of all, this repeated product is going to cancel out this entire thing except for the very last term, because this one has one more term than that one. Similarly, this factorial is going to cancel out all but the n plus 1 in that factorial. And 2 to the n and 2 to the n plus 1 is just going to leave a 2 in the numerator. So everything we have left is 2 times n plus 1 over 3n plus 5. Everything else canceled out. So for the ratio test, we're doing the limit as n goes to infinity of this. And remember that if it's less than 1, we have convergence. Well, these are the same degree. They both have n. Our coefficients are 2 and 3. So this is 2/3. 2/3 is, of course, less than 1. So we would say that this converges by ratio test. And since our series independent of the alternating part converged, that means that this series is absolutely convergent. Because if a series converges, its alternating form is guaranteed to converge. That's what absolutely convergent means. So not only does it converge, it's absolutely convergent by the ratio test.